show, in order to show that two functions are inverses of each other, we have to prove that not just two pairs of points are inverses, we have to prove that all pairs of points are inverses of each other. Which if you think about like using actual numbers to do that, that's impossible, right? Because there's always another number. So we can't actually prove it by plugging in numbers. That's not a thing. So what we have to do is we have to use algebra instead. So flip the page over. And to verify if one function is, or if two functions are inverses of one another, not if one is an inverse of the other, but if the functions are inverses of one another, we plugged in numbers to see what happens when we plug in the numbers, and we found that we did get inverse values of x's and y's, but what do you think we might need to do in order to show that two functions are inverses of one another? Any thoughts on that? All right, so here's what we're going to do. We're not going to plug in any values for x. We're actually going to plug one function into the other function. So in order to figure out, in order to verify if functions are inverses, that means when we take f of g of x, we're going to replace x with the entire function of g of x. So in place of x, we are going to write, we're figuring out f of, what is g of x, by the way, over here? What does it say g of x equals? X minus 1 over 2, right? So we're not figuring out like f of 2, f of 4, f of 5. We're figuring out f of x minus 1 over 2 because that's what g of x is. So we're going to say, all right, f of x minus 1 over 2. So we're figuring out the entire function as it relates to f. We're using the g of x values here. And so what that means is we're going to rewrite the f of x function, but instead of using x, every time we see x, we're going to replace it with this, x minus 1 over 2. So we're going to say 2, parentheses, x minus 1 over 2, plus 1. So we're taking the entire function of g and plugging it in for x in f of x. Any questions about that before we continue? Okay, we're going to have to do this twice, by the way. We have to do f of g of x, then we're going to have to do g of f of x to make sure that we end up with the same thing. So when we multiply this all out, let's see, that'll be, I'll just write equals down here, 2 times x minus 1 over 2. Well, actually, we could distribute the 2 to the numerator here, to the x and the minus 1, but I think it'd be easier just to cross cancel, or not cross cancel, but just cancel out the 2's. Because the 2 here, the whole number 2 is like a numerator of a 2, and there's a denominator and a numerator, and denominator with multiplication means you can just cancel them out. So that'll give us x minus 1 plus 1. We can drop the parentheses because the multiplication is now gone. And all we're left with is the numerator here, which is x minus 1. And then we add 1 to that. What happens to the minus 1 and the plus 1? What's negative 1 plus 1? 0. Yeah, they cancel out. So we're left with x. So f of g of x is x. All right, now over here, if these are inverses, then g of f of x should also give us a value of x when we're done with that. So this time, instead of plugging in, so here's g of f of x. So this time, instead of plugging in x minus 1 over 2 for x, we're going to plug in the function for f in for x this time. So this will be g of 2x plus 1. So everywhere we see x in this function here, we're going to plug in what f is, which is 2x plus 1. So it's substitution. We're substituting a lot, and then we're doing some algebra. So on the numerator here, we're going to have 2x minus 1 sorry, 2x plus 1 minus 1 over 2. So we're taking the value of x here, and we're swapping it out with the function f of x, which is 2x plus 1. And then we'll go ahead and simplify the numerator. Now, the parentheses here don't actually mean anything because we're not multiplying by anything, so they didn't have to be written in the first place. So that basically means we can go ahead and take our -1 and our +1, and those are going to cancel out on the numerator. And that's going to give us 2x over 2. And then what does 2x over 2 simplify to equal? Yeah, 2's cancel out. We're left with x. So we have shown that 2x plus 1 and x minus 1 over 2 are in fact inverses of one another because they both equal x when we basically nest one function inside the other. Any questions about that process before we look at the next two? We'll be a little bit quicker with these next couple ones. All right, let's do the next one, B. So we're looking at f of g of x. So we're looking at f of x minus 5 because g of x is x minus 5. So this is f of x minus 5, which means this will be a lot quicker because here we're going to plug in x minus 5 for x. And so that's going to be x minus 5 and then plus 5. This one's going to be a lot faster, by the way. -5 plus 5 is 0. So the 5s and the -5s cancel each other out and we're left with x. So here we go, equals x. All right, now we'll test the other one, g of f of x. We're plugging in f of x, the function inside here. So that'll be g of x plus 5. And that's going to equal the function g, but we're replacing x with what the function f is. So x plus 5 and then minus 5. And once again, the +5 and the -5 cancel each other out. And we're left with x one more time. So equals x. There we go. Both functions end up equaling the same thing. Cool. Let's check out what happens if you have a cubic function as opposed to linear, because these first two were linear. Now we have exponent of 3, so we have to see if, are these cubic function inverses of one another. Starting off with f of g of x. So f of g of x, which means we're going to be plugging in the cube root of 2x everywhere we see x over here. So this is going to be f of the cube root of 2x. So when we write f of x, that's going to equal 8 times the cube root of 2x cubed. Okay. Let's see. What's the cube root of 2x cubed going to equal? Any thoughts on that? What happens if you cube a cube root? Cancels out. So this would equal what? What is it? Yeah, it's going to be 8 times 2x, which would equal 16x, right? All right, see what happens when we do it the other way. Making sure I wrote everything correctly there. Yeah, it looks good. Okay. So over here, we're going to take a look at g of f of x. F of x is 8x cubed, so it's going to be g of 8x cubed. So everywhere we see x over here, we're going to substitute in 8x cubed. So we're going to go with the cube root of 2 and then parentheses, plug in right here, 8x cubed. I'm looking here. Hang on just a second. So let's see, G, so that's going to be what? What is this going to turn into? What do you think's going to happen here? So you could do that, but you'd probably end up just kind of splitting it apart anyway. Because this would be, wouldn't this be equal to the cube root of 2 times the cube root of 8x cubed? I mean, we could write it like that. So, 1 second. What is the cube root of 8x cubed? Because we did that over here. Or no, we didn't do the cube root of 8x cubed, but we did the cube root of 2x cubed, which is basically this. The cube root of 8 is what? What's the cube root of 8? 2, right? What's the cube root of x cubed? X. Okay. So that means that this is going to equal 2x times the cube root of 2. Are these inverses of one another? No, they don't equal the same thing. So this one right here, those are not inverses. So A and B were inverses of one another. This one, not inverses. All right. Getting close. So you can test it like that to see if things are inverses of one another. All right, let's flip it over. This is our last problem here. Cool. Solving real life problems. So in many real life problems, formulas contain meaningful variables such as the radius r in the formula for the surface area of a sphere, which is surface area of a sphere is equal to 4 times pi times the radius squared. In this situation, switching the variables to find the inverse would create confusion by switching the meaning of s and r. So when finding the inverse, solve for r without switching the variables. So basically it says find the inverse of the function that represents the surface area of the sphere, then find the radius of a sphere that has a surface area of 100 square feet. So first thing we're going to do is we're going to solve for r. And we're going to do that by, I mean, it says finding the inverse of this function is not going to work by switching the variables because it would change the meaning. And so instead of flipping the variables, we're just going to get r by itself to figure out what the radius is. So solve for r, basically. So solve for r. So that means we're going to write, I'm going to flip the entire equation around. 4 pi r squared equals capital S. And then let's get r by itself. So we can get rid of the 4 times pi by dividing away 4 times pi. So just divide by 4 pi on both sides first. 4 pi's cancel on the left. And that's going to give us r squared equals capital S over 4 pi. Nothing to reduce there. It's just a fraction. And then to get r by itself, what are we doing? Square rooting. Good. Now, generally, when we square root an unknown variable, we end up with positive and negative, right? But this isn't, we don't know what the number is for the variable, but we do know what the number represents, and it represents a radius. Can the radius of a circle be negative? No. So we're not going to do plus or minus the square root of this. We're just going to write r equals the square root of that. So the radius is equal to the square root of the surface area divided by 4 pi. So from there, it's just saying to find the radius of a sphere that has a surface of 100 pi square feet. So this is basically saying S is equal to 100 pi. So here we're going to say, all right, I'll just do this, put this over here. S equals 100 pi, comma, find R. And since we have R already solved for, all we have to do is substitute in 100 pi right here and then solve for R. So this is going to be R equals the square root of 100 pi divided by 4 pi. What's 100 divided by 4? 25. So that's going to be equal to the square root of 25. What's pi divided by pi? 1. So the pi's cancel out. So what's the radius? 5, yeah. And we're looking at feet. So radius equals 5 feet. And that's it. So try B on your own. Work through that one a couple minutes, and then we're done with our notes. We're done with chapter 5 in general. When we get back, we're not going to start in on the new text right away because we have to finish up reviewing for our test and taking the test for chapter 5 first. So once we start in chapter 6, then that's when we're going to start in the new book. So go ahead and work through part B.
Yeah.
Got it, Harley? You tired? I was going to say, you look like you're fading quick.
What?
Were you up late?
No.
Were you out late? Wrestling? No, just hanging. Okay. I was out late last night too, actually. Which is not normal for me. I didn't get to bed till like 11, which is like way past my bedtime. It was worth it though. Because we won team trivia. So.
I have my test.
Yeah. Anybody have an answer? Anybody have an answer for B? No answers yet? Anybody have a function for T? What does T equal by without any numbers? Hopefully we got that. T is equal to the square root of D divided by 4.9. Hopefully. So if D is 50, if it drops 50 feet, if the distance is 50, how long does that take? Approximately. do 1 decimal or 2, doesn't matter. Anybody? Once somebody has it, let me know. Mike, you got it? No? Ricardo, you got it? Yeah. That's 3.19 seconds. Cool. So get t by itself. So divide both sides by 4.9, then square root. And then substitute 50 in for the distance. And then just type in square root of 50 divided by 4.9, you get about 3.19 seconds. If you said 3.2, that's fine. Cool. So that's it. You have the rest of the class. We got 45 minutes as work time. So whatever you need to be working on, catch up on whatever you need to do.